This movie explores the construct of authenticity. Authenticity consists of three subconstructs, and in this movie we focus on two of these, that of task and that of tool. Here we see the continuum for task and tool, and as in an earlier movie, you'll remember that each of these continua is separated by binary terms, in this case decontextualized at the weaker end and realistic at the stronger end. And in the case of the subconstruct of tool, we're using the term artificial and practitioner-like. So this movie will explore and illustrate what these look like in terms of mobile technologies. We should point out that often it's the case that there is a middle ground, and in this case we've used the word simulated to indicate the middle point along the continua for task and for tool. This video illustrates some examples of students using mobile technologies to undertake a task, and these examples range from extremely contrived uses of mobile technologies through to very realistic and practitioner-like uses. Many tasks undertaken by learners, especially those situated in the classroom, are very contrived or artificial in nature. Using mobile devices to undertake such tasks makes them no more authentic, such as these examples in a school where students are using simple drill and skill applications to develop basic mathematical concepts. There is no attempt evident in these examples to situate the task in a realistic setting linked to the work that mathematicians would do in their own communities. In this second example, which is also set within a school, students have been asked to use their mobile device to practice the kind of activities they might encounter outside of school in their real life. The teacher has set them to use their iPod Touch and an app for measuring angles to identify a variety of real angles in the school and around the classroom. Students walk around the room and the school measuring the corners of the blackboard and the angles of the greenhouse roof in the playground. In this scenario, the school is used as a practice field, and in these examples, their mobile devices enable them to undertake a simulated activity which will help them to understand angles in their own life beyond the school. In this second example, a similar example set this time in teacher education, we see how two academics from the University of Technology, Sydney, have set their students a series of tasks associated with real-world learning around Sydney. In these examples, students use their mobile devices to identify geometric shapes and to annotate those shapes, as you can see in the pictures. Although the physical setting is located outside of the university, this is still regarded as a simulated activity rather than a participatory one, since there is no indication in this example that the students are working with a real community of mathematicians. In this final example, under a participation model of authenticity, students participate in the actual world of a professional community, engaging directly in the target community itself. This is still rare in schools and even universities, and it's not surprising, therefore, to find few examples of this using mobile technologies. Nonetheless, mobile technologies offer many opportunities for learners to join real communities of practice, and this may be undertaken without even the classroom. For example, in one primary school in Scotland, learners under the age of 11 participated in a real community of artists who viewed their work, which they produced on their iPod, and offered them expert feedback, as we can see in this short clip. In this final example, we see a similar use of mobile technologies to support a participatory form of authenticity. Here, school students can be seen using their mobile devices out of school on a field trip as part of a citizen science project, where they collect data to feed into a genuine community of real scientists. In this sense, they're working in a highly participatory setting, and this could be replicated in many other subjects and discipline areas, even if, at the moment, this is not yet common. So that video illustrated some of the activities classed as task, where students used a mobile device in more realistic settings, and some examples as well of simulated or even contrived settings. So what we're going to focus on now in the last part of this movie is to talk about the subconstruct of tool. And tool overlaps with the idea of task because many of the tasks that students undertake will use tools. These could be apps on their device, they could be features such as the camera, the audio recording device. And at the more realistic level, these tend to be like the tools that practitioners would use in a professional context, as opposed to artificial tools that are unlikely to be used outside of school. These are some examples. Scope Pro, for example, records audio, very similar to the kind of devices that professionals would use. Easy Light Meter records light levels, again similar to the kinds of devices and tools a professional would use if they wanted to record light levels in a building. BP Companion records heart levels, heartbeats, and Wind Tunnel Pro can be used to simulate what it's like for example, in this instance, a car in terms of aerodynamics. So this is often used by professional people, for example, testing cars, testing aeroplanes and wing design. But all of these apps are available on a mobile device, and they replicate the kind of professional activities, the professional tools that we might see being undertaken outside of school contexts. This is another example. Although this is not something which a professional might use, it does replicate the kind of data that real geographers might be familiar with. So this is about earthquakes, and this illustrates how we can collect data using an app of real-time earthquakes taking place around the world. So each one of these dots represents an earthquake. The app is called Quake Spotter, and there are a number of these apps, and it's recording live data. The setting has been set here, in fact, for the last 12 hours. So each of these dots represents an earthquake that took place relatively recent. And this data is fed into the student's device. And of course, in a subject like geography or geology, this would be incredibly realistic and meaningful. And you can see here that we can drill right down to the level of actually finding out where the earthquake occurred. This is a website that's linked to the app. And if anybody actually observed that, they may have uploaded some images. So using an app like Quake Spotter Pro, we can bring real-time data into the classroom. And that is pretty realistic and meaningful for students in terms of understanding a topic like geography. So taken together, the task and the tool subcontracts illustrate the degree to which learning is deemed to be authentic, realistic, and meaningful from the perspective of students.